Okay, so as we were literally just discussing a minute ago, uh, when it comes to things like scope in variables and variables in general in Python, there's a lot more to it than just saying this equals that. So we're going to be learning about different types of variables and how to use them. And in general, in Python, there are 5 types of variables. So there are local variables, instance variables, class variables, global variables, and constants. So we're going to go over these one by one. Does anyone have a guess about what I mean when I say local variable?
Just in one function.
I'm sorry?
It's just defined for one function.
Mm-hmm. So very, very close. They are available in one function, but kind of to expand on that a little bit, they're only available in the block in which they're initialized in. So that includes functions, and it also can extend to things like loops. And when we define things on a global scale, in some ways they're defining them similarly to a local variable. They're just available in that larger block, the biggest block we've got. And usually, they're only available in the block they're initialized in. And they almost always start with a lowercase letter or an underscore. And when it comes to local variables, if you try to read them before they're created, so if I say, if I do print I and then after that do I equal 1, it would break. So it'll raise an error if they're read before creation. And they're the kind of variable you're going to use the most often. So if I use an example here, if I do my name equals Noah, I can print my name here because I am referencing it after I create it, and it's done in the same block as it. So I do run this again. There it is. If I try to do print my name before it's defined, it doesn't work. And then we can also do stuff like this. Well, I'll keep that the way it was. And I can do something like def print name. And then I can tell print name to take my name as a argument and print out my name. So now if I do print name and pass it not Noah and run that, what do you think is going to be printed when we call the function? Noah or not Noah?
Not Noah.
Yep. So when the function is called, it prints not Noah. So even though my name is a variable declaration here and one here, what we've essentially told Python is, all right, within this block, within this function, we have a variable called my name, which is defined right here. And when Python encounters a variable name, the first place it'll check is within the block it's in. And as soon as it finds a variable that matches, it'll just print it, stop and just go with that one immediately. So if I took out this reference to my name here, and then also take out the argument here, as we've seen, it'll work because it'll say, okay, I'm supposed to print something called my name. I can't find it within the block I'm in, so I'll go up one level and see if it's defined there. And so situations are like this are why you always want to make sure that you change up your variable names, because depending on scope, you might get a little bit confused and call on one variable when you meant to call on a different one.
So that last part you just said, so sounds like you're saying best practice is you should name your global variables with a different schema than you name your local ones to help distinguish them.
Doesn't necessarily have to be with a different schema, but you should definitely make sure that you aren't repeating variable names whenever possible.
Okay, so yeah, so they need to be unique.
Yes.
Okay.
And it'll still, as we've seen, it'll work if they're not unique, but then that's causing undue trouble for yourself and other programmers you might be working with.
Right. Okay.
And yep. And another thing we've seen is you can assign multiple variables in one line, like we did during our bubble sort algorithm. So I could do A, B, and C is equal to 1, 2, and 3. And if I print out A, B, and C, oh, I forgot a comma. There we go. 1, 2, and 3. So if you ever have to define multiple variables at the same time, and you know exactly what they're going to be, you can just separate them like commas like this, and it'll automatically assign them in the order you type them in. All right, that's local variables in a nutshell. Any questions about how these work?
I had actually one question because I've seen that format used basically kind of like to unpack tuples. Now, with this style, variable name, comma, variable name, equals a list, would that also still work in JavaScript too, syntactically?
So just to make sure I know what you mean, are you saying like would this work is what you're saying?
Yeah, well, no, I'm just saying if line 18 would work equivalently in JavaScript, assuming that you have to do let A, let B, because I'm used to doing let A, let variable name equal and a value.
Yeah,
So in here,
let's try
I know
that out.
Python, you can actually, you don't have to use the let, it'll test it on its own. So.
Yeah.
I think Java's, yeah, okay, never mind, you found it.
Yep. So JavaScript doesn't do that kind of natively necessarily, but you can do something like this. So array A, B equals 10, 10, 10, 20. And I believe that you can also do what's called destructuring, which is something we'll kind of, let's see if they have a array destructuring. So for example, they had here, you define const and then an array of variable names, and then you set that equal to an array, and it destructures them. So red is now equal to the first thing in the array, 2 and 3.
I guess that's almost like an object or a dictionary to a certain extent. Just like what for this deconstructing, or I guess mapping is another term. So, okay.
Yeah, so it's very similar to that. And destructuring is something we're going to be doing a lot more of when it comes to things like React later on in the program. But in the meantime, yeah, so using this method right here of destructuring, you can do mass assignment of variables in JavaScript as well. All right, let's move on to instance variables. So where do we find instance variables? We've used them a few times now.
Like when you make an object?
Yeah, so instance variables we define them within classes in this case. And an instance variable always begins with what keyword?
Self?
Yep, with self dot. So defined within a class, and specifically defined within a class during initialization. So these are also a type of variable you're going to be using all the time. So going back to a previous example we've done, if I make a class called employee, I can create an initialization method that always takes self as an argument, and then let's give it a first name a last name, and pay. To define my, so what do I need to do in order to define my instance variables?
Self dot.
Yep, so self dot first name equals first name. Self dot last name equals last name. And self dot pay equals pay. And remember, your instance variables, the names of your instance variables don't need to match up with the names of the arguments you give. So I could do self.first equals first name, and it'll know what I'm talking about. Just the idea here is that I've created a variable that belongs to every instance of my class called first name. So every class, every object of employee I make will have access to a variable called first name and last name and pay. And we can also define instance variables that have nothing to do with the arguments we give the initialization function, or very little to do. So I could say self.email equals first name dot last name at company.com. And even though I didn't define email as one of my arguments in my init function, every employee will still now have an instance variable called email. And you can access those through methods. So I could say, def say hello. And to access them, I would just say print, hi, my name is self.first name, self.last name. You can reach me at self.email, and I earn self.pay. You can put a little $sign here. So now I can create a new employee object. So I could say Noah equals employee. I can say Noah.sayHello. All right. Any questions about instance variables? And just demonstrate another thing, I can always access an instance variable from outside by saying Noah.firstname, like so, and accessing it that way. All right, now let's talk about class variables. So class variables, they look the same as local variables. When you define them, there's no difference. But the only distinction is that they are defined at the top of a class. And so does anyone remember what the distinction is between an instance variable and a class variable?
The class variable is going to be shared amongst all the instances.
Yes. So a class variable is shared among every instance of a class. So when we look at our employee variables here, so if I define one variable called Noah and another variable called Tom, Noah and Tom will have their own instance variables, and neither of them have access to the other ones. But I can create some instant class variables, like number of employees, start it out to 0 and say raise amount equals 1.04. In that case, both these instances will have access to the number of employees. So if I do, I'm going to create Tom equals employee. So if I do Noah dot number of employees, I'm going to make sure I print that out. I can also print out Tom dot number of employees. And then I also print out employee dot number of employees. What the heck is going on? There we go. So they all have access to that variable. So both the instances and the class as a whole. If I want to interact with them inside the class definition, generally, we talked about how if I say self.number of employees, it might be a little confused and be asking, wait, do you mean the class variable number of employees, or are you creating a new instance variable called number of employees? So to make sure that error never happens, generally speaking, if you're interacting with a class variable when you're inside of a class, you just want to use the class name. So that way you don't have to worry about anything like that. So now if I do something like this, so the number of employees variable keeps going up, and Tom, Noah, and the employee class all have access to it. So I could do Tom, that number of employees, and they would still remain the same. All right, what questions do you have about class variables? So generally speaking, class variables are useful, but I would use them sparingly. So for example, just always, whenever you're deciding whether or not you want to use a class variable, consider, is this something that every instance of the class needs to have access to? So in this case, for example, number of employees, it makes sense because every employee may need that number, that variable, is relevant to the employee class as a whole rather than each individual employee. Raise amount, on the other hand, if it never changes, maybe we'd want to make that an instance variable and just say self.raiseAmount equals 1.04. But if it's something that's true for every employee, and if it changes for one person, it changes for everyone, then maybe we'd want to keep it as a class variable. Okay. So we've talked about this a bit today already, but global variables. So when we talk about global variables, we talk about global. What do we mean by that?
Their access to the entire program?
Exactly. So their scope is the entire program. So when we say global scope, that means literally everything. And to bring them into a function body, we use the global keyword. And I also mentioned this before, I'll say it again. Generally speaking, you'll want to avoid global variables. There's not really that many cases where you would really want to have some information available globally. It can be messy, and it's considered a code smell by most people. So generally, anything you can accomplish with a global variable, you can usually accomplish by, for example, reassignment from a function call rather than bringing that variable in. But it is an option if at any point you need it. So if I go down here again, so I do number equals 101. I can print out number here. I really wish I'd stop doing that. So it prints it out just like so. And right now, this is a global variable insofar as that it is available in the global scope, but it's not available in a function call yet. To do that, I would need to again make a function called some function, and I would have to say global number, meaning I want you to look in the global scope for this variable. So I print number here, and then call some function. That gives me access to the global scope. That's really all there is to it to global variables. Does anyone have any questions about those? Okay. And then the last variable we're going to talk about are constants. So does anyone know how we define a constant in Python? Excuse me. In JavaScript, it's easy. You just use the const keyword. But in Python, it's a little bit different.
Oh, go ahead.
I was going to say typically it's just all capital letters.
Yep. So you define them in all caps. And we define them, we call them constants because the idea of a constant is you never want the constant to actually change. Whenever you define something in all caps like this is you telling other programmers, never reassign this variable, never alter this variable in any way. I want it to remain the same at all times. Otherwise, it's more or less identical to a local variable. It's like a local variable. It's only available in the scope of definition. So I could, again, comment to that. Oh, get out of here. So if I wanted to say, make a function called count to 10. I don't know. This isn't how I would normally define a function, but I could say numbers equals 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, what's going on here? Why am I getting okay, we're good. Then I could say, for num in numbers, not in name error. So if I call on count to 10, it should just, work like any other variable. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I did this, numbers.append 11, what do you think is going to happen?
It'll just add 11 to the list and it'll print 1 through 11.
Yep. So in Python, when we define a constant, there is actually nothing preventing you from changing that constant, even though you're not supposed to. It's entirely just a convention. So whenever another developer sees, oh, this is a constant because it's defined in all caps, I know if I'm going to be editing this program, I shouldn't mess with it in function calls or anything like that. So a constant is just essentially a fancy local variable. Not even that fancy, really. It's just shorthand. All right. Any questions on variables before we move on to another thing? Another topic, that is? So in the chat, making sure there's nothing I'm missing there. All right, so Julian mentioned that numbers wasn't changed, the list there was. The same thing would happen in JavaScript with the const. Changing the reference would be changing numbers. That's a good point. Thank you, Julian. All right, so I'm going to talk a little bit more about objects and specifically a new way of instantiating them. So for example, I'm gonna make another class called address. I'm gonna say def init. And an address is gonna take a lot of things. It's gonna take a first name. It's gonna take a last name. It's gonna take street 1. It's gonna take street 2. It's gonna take a city, a state, a country, and a zip code. And then we need to do self.firstname equals first name, self.lastname equals last name, self.street1, street 2, self.city equals city, self.state equals state, self.country equals country, and finally self.zip code equals zip code. So I don't know if that was as boring for you to watch as it was for me to type. And if I wanted to, define a new address, I'd say, address, Jeremy, Jordan, 123 Fake Street, apartment, no, Seattle, Washington, USA, 98115. So taking a look at this, what's a potential problem that I've created for myself when it comes to creating a new address object? What could go wrong here?
You might put the apartment number before the street number.
Yeah, I could easily mix up street 1 and street 2. And generally speaking, you want street 2 to be a different, it should be an optional thing. Not everybody has a second street address. So essentially, I've made this problem with myself where I have to write these out in the correct order every time, or even more tediously, I'd have to write first name equals Jeremy, last name equals Jordan, street 1 equals fake street, street 2 equals apartment no, all of that. So what I'm going to do is I'm going to edit my class so that instead of taking a several strings as an argument, it's only going to take a single dictionary. So I'm going to replace all of these arguments with something called address info. So then I can just replace all of these with address info, like so. So then when I want to create my object, I could say, all right, address info equals. And then I still need to type all this out. There's no getting around that. But it's going to be, just generally speaking, a lot neater, and it's going to be easier in my init function. So I still need to do all this, but because then I can do something like, street 1 is 123 Fake Street. And I don't need to, if I don't include a street 2, I don't actually have to now, because I would need to make sure that when well, let's try this out, see what happens. And I can also change the order up. All right, so now if I just instantiate address, I can just instantiate it with address info. Uh-oh. Oh, I need to make these strings. Like so. My bad. Thinking in JavaScript again. There we go. That should work this time. Nope. All right, so now we still have a problem where it tries to look at something called street 2 and doesn't have it. So I could do something like this. No, that doesn't work.
No, it's because you're using the brackets. It's using the brackets on a dictionary causes a key error to get raised. So if you use .get, because it's a dictionary, the .get method will do exactly what you just typed.
So
if it can't find it, it will return none.
So I believe that's how it works. Oh, I forgot to put in country as well. So as you can see, this doesn't automatically make your life easier in every way. Now we don't get any errors. But it does make things cleaner. And it gives you a little more control over how you do things. Initializing with a hash is just, generally speaking, a little cleaner. Easier to edit the information before you put it into your definition down here. And yeah, just makes things more clear and clear. So I would just recommend when you're creating a new class object and you have many, many different keys that you need to assign, just use a hash. And as we found out, instead of just accessing the key directly, if it's optional, you can just use .get. And .get will either give you it'll either give you none or the value. All right. Any questions before we break for the day? And by break for the day, I mean stop lecturing and then get 2 challenges.
I had a question about our meetings with Rod. Sorry if I missed it before, but how are we actually conducting the meeting?
Good question. Is Rod here right now? I thought I saw his iPad was joining the meeting.
Yeah, we'll do them by Slack. All the Slack video calls.
Okay, thanks.
Hi, Noah. This is Nisha.
Hey, Nisha.
I'm not sure if I understood what you were doing in your constructor. But you're just building a dictionary.
Yeah. So what I've told my constructor here to do is I told it to expect a dictionary. So technically, I could pass in just a string here, and it would break my program. But what I told it is, okay, you're going to get something that we're going to call address info. And I want you to treat address info as a dictionary and expect to see these keys: first name, last name, street 1. And the way I've written it right now, if it doesn't have most of these keys, it'll break. But essentially all I've done is just said, instead of giving
I see it. Yeah, it's just a little, I didn't see that down there.
Yeah, so this is where we defined the information we're giving it. Okay. Any other questions? All right, in that case, I'm going to stop recording and then talk a little bit about the challenges for today.